All right, let's get going. So welcome everybody. I know some of you are still trickling in, but we've got an action-packed schedule for the hour. And today, in case you've just stumbled upon this webinar, today we're talking about Bluetooth. Before we go too deep, I want to start by giving you a couple logistics points. First, we're going to have an open conversation for about 45 minutes. We'll have time at the end for questions. If you want to ask a question, you can use the Q&A button in the Zoom UI at the bottom. You can enter questions, we get to see them, and we'll then pick them up and answer them either live or write up a response time, depending on the time and how many of your questions you have. Feel free to enter a question at any time. If it's particularly relevant to the thing we're talking about in this very moment, we will maybe even answer it, in line. Otherwise, make sure to stay till the end so that you hear the answers at the end. Today, I am glad to be joined by my co-founder, Chris Coleman. Chris is co-founder and CTO here at Memfault. He's a incredible firmware engineer who's worked on a number of devices, including Fitbit fitness trackers, the PAwR watch, where we worked, that we both got to work on, and big servers at Sun Microsystems. He's done a ton of Bluetooth debugging, perhaps more than he should or anyone should have to do. I myself, go ahead,
particularly
Chris.
excited about this topic today.
Oh yes,
Bluetooth and the journey we went through, transitioning from Classic to BLE at PAwR, and then Fitbits, near and dear to my heart.
I ran out of questions to ask you, so invited a group of 40 or some and counting friends to help me out. I myself, my name is François Baldassari. I'm the founder and CEO at Memfault. I'm also an embedded software engineer, having worked at Sun with Chris and at PAwR. Most recently, before I founded Memfault, I worked at Oculus on virtual reality headsets. Some really gnarly coexistence issues, let me tell you, when you're trying to both do streaming of very data-intensive games, as well as connecting over 2.4 gigahertz with connectors. So I had my fair share of Bluetooth debugging. Memfault, very briefly, for those of you who don't know, is the first observability platform optimized for embedded devices. We help companies like Latch or Logitech understand how their Bluetooth devices and many others are performing. And when they don't work right, we help them fix it. Check us out, memfault.com, in case you haven't heard. But I assume if you're here, you've heard about Memfault. Last but not least, I have joining us today Simon from Blecon. Simon is one of the founders at Blecon. Simon, I'll let you introduce yourself. Tell us all about you and Blecon.
Oh, sure. Yeah. So, yeah, Simon Ford, based in the UK, in Cambridge. Yeah, long time, I guess, engineer in the embedded space. So a lot of time with ARM, doing all sorts of radio standards, embedded software, silicon design, that sort of stuff. And yeah, more recently with Blecon, where we're very much focused on Bluetooth Low Energy and cloud connectivity.
Awesome. Thank you, Simon. Do you want to tell us a little bit about Blecon?
Oh, sure. Yeah. So, our focus is on enabling people to use Bluetooth Low Energy to connect to cloud backends rather than, these sort of personal paired relationships. And I'm sure we'll get to talk about all the reasons why people are trying to use Bluetooth. I mean, it's an amazing technology with amazing economies of scale. Not necessarily the first choice you would think if you were thinking, how do I connect to the cloud? But so many reasons, technical and economic, why people are trying to do that. And yeah, that's what we're building. So Bluetooth network.
Awesome. I look forward to the conversation. So as you all know, we've got some experts on the call today. And then we have me to try to moderate and guide the conversation. Let's start with a little bit of history. So Bluetooth's been around for a while, right? Like first devices coming in the late 90s. Obviously, we're not going to go through an exhaustive play-by-play of the history of Bluetooth and the emergence of BLE, but perhaps perhaps Simon, you can start by giving us kind of the standout, the key moments for you.
Yeah.
What do you
Well,
think
yeah,
of when you think of Bluetooth?
Yeah, I mean, I guess, yeah, Bluetooth, when it, yeah, as you say, it was introduced around 99, 2000. That was the sort of Bluetooth 1 era. I was at university coding a Bluetooth stack when that was first coming out. So that was very exciting. And the era was PDAs and trying to do file synchronization and, you know, a classic cable replacement technology. So things like OBEX to, you know, sync your diary between your PDA and whatever. And then a bit later, you know, I guess, what was it, 2004 or something like that, you get Bluetooth 2. And the real killer app that sort of, I guess, got it to prominence was wireless headsets. You know, so early mobile phones talking to wireless headsets so people could be driving while having their very important business calls. And, you know, that made companies like CSR and, Cambridge Silicon Radio, now part of Qualcomm, but, you know, it really, that got Bluetooth going, I think. Yeah. So that's the sort of era it started. And obviously things started to change with Bluetooth Low Energy. But yeah, I think a lot of people remember Bluetooth for audio. That's, you know, what really got it into so many devices.
When you think of Bluetooth 1 and the earliest versions of the Bluetooth protocol, you know, how different were they? Is Bluetooth 4 or Bluetooth 5 that we may use in more recent devices, does it have anything to do with Bluetooth 1? Is this, do they share a name, or do they actually share technology?
Well, that's an interesting story. So I guess, yeah, the Bluetooth brand is incredibly strong, right? Everyone knows Bluetooth, but perhaps, yeah, the difference between like the Bluetooth, now Bluetooth Classic, and Bluetooth Low Energy isn't so clear. But actually, yeah, Bluetooth Low Energy, which, as you say, that came in Bluetooth 4, which is, you know, a bit later. Actually, iPhone 4S was the first thing to introduce Bluetooth 4. Actually, quite different technologies. So Bluetooth Low Energy started as a project in Nokia called Wyberry. And I was lucky enough to be around Nokia at that time because I was building chips or helping build chips and architecture for phones at the time. So that's actually how I found out about Wyberry. But later on, the Wyberry working group or whatever, so the concept behind Wyberry was, hey, you know, it's not just about connecting high bandwidth, you know, relatively power hungry things. There's that Nokia could see that there was these other peripherals that were going to be connected to phones. So they had this, yeah. So different technology, different trade-offs. And then the Wyberry working group a bit later was merged into the Bluetooth SIG. And then a few years later, that came out. Well, originally, I think it was called Bluetooth Lite. Then it was called Bluetooth Low Energy. Then it was called Bluetooth Smart. Then it was called Bluetooth Low Energy again. You know, so a little bit of a branding hiccup there. But yeah, Bluetooth 4, I think, is where things really started to kick off as Bluetooth Low Energy came in and started to really, you know, push new applications beyond what I guess people would have originally understood Bluetooth Classic to be. So I mean, that just I did actually write down a date for this. So
as someone who jumped into kind of reading the Bluetooth specification between like the transition from Classic to LE, what I really appreciate is where LE started was much simpler. Kind of the concepts and the fundamentals and just kind of how data was transmitted was easier to sort of jump onto and comprehend and get things out the door. Because as you said, initial use cases feel like they're really designed on these peripheral based lower bandwidth. Hey, someone's going to have a heart rate sensor. They're going to have, you know, something that's connected and just sending, you know, temperature or heart rate or status reports to a phone or another device. But I think that would have been around 2010, I think, if memory serves.
Yeah.
Chris, any other? So go ahead, Simon.
Yeah, no. So I was going to say, yeah, Bluetooth 4 is really where, you know, those two technologies came together, and you know, in some sense, Bluetooth Low Energy got a free ride on the Bluetooth chipsets that were already in phones and laptops and things like that. Because, you know, if you're a chip guy and it's not that expensive to add this Bluetooth Low Energy technology to a chip, you know, it's risky not to add it. And if you're a phone or laptop manufacturer, it's risky not to add it, and the cost of adding it is very minimal. So actually, as a way of deploying what is fundamentally quite a new, different radio technology, it had this sort of on-ramp, which, you know, very few other technologies have the privilege of that sort of on-ramp of both the brand, but the deployment channel. So a lot of people talk about, you know, radio technologies and, you know, it's all about the technology. You know, the reality is successful things, it's not just about technology, it's about, you know, distribution. It's about economics of fundamental economics of how much does this cost in silicon die or something like that. So yeah, a really, really interesting sort of coming together, I think. And yeah, that was the iPhone 4S, which was the first one. Yeah, the first, well, it's the first smartphone to have Bluetooth 4 in it. I mean, I think, yeah, what a coming together of like some really interesting technologies.
I always think of that as solidifying the fate of BLE at the time. Back then, I feel like there's several different directions or where things could have gone, but kind of being first in on the iPhone, to your point, riding on, you know, Classic already being in place and being there, sort of just the mass adoption of iPhones. I think that's really what got Bluetooth LE to the place it is today, adoption wise.
Yeah.
Chris, on the technical sides, are there any, you know, thinking about the evolution of Bluetooth as a technology, are there key features that you've seen emerge over the past, you know, decades that you think are really notable and change the game in Bluetooth?
Yeah, I mean, a few things stand out to me. I think what's always impressed me about Bluetooth SIG and sort of how they think about the problem space is really listening to use cases and sort of thinking about like, how can we make the technology better to meet a wider and wider array of use cases that are there. So when BLE first came to existence, focus was really on these very simple peripheral sensors, sending small amounts of data, being super low power, right? You want devices that can last for years and send in updates once a minute, something in that scheme. And over time, with sort of developer APIs that were added on, you know, the iPhone and the Android side, it was clear this was just an easier technology for people to pipe more data and a lot more data from different, you know, from peripherals or from other devices. Started to lead to the question, you know, how do we sort of maintain this low power profile, but how do we also expand to meet use cases where people want to send more bytes or more data than they could push through? So like, long story short, over the years, like, there's been a lot of investments and features that expand to those use cases. This is sort of what's allowed for support for audio streaming over Bluetooth to roll out. I think
BLE.
of like over BLE, yes.
Yes.
You know, feature set wise, like ones I get excited about are things like packet length extension. This kind of lets you pack more data in the same payloads that are sent, so you can get sort of much better throughput. The I guess other areas, all started on a 1 megabit PHY, but sort of the modulation scheme was picked up, so you could send more data that's there. I think that's really interesting for sort of meeting these use cases. And then I think actually in the opposite direction, there's also use cases where it's like, hey, we don't want to send a lot of data. We want to be really low power, but we want to be able to send this data over a much longer space. And that's where kind of with the rollout of, there's a BLE long range support that was added, which I think is super interesting. Basically, it's the same output power. So sort of no extra power gain, but what they do is they crank down the amount of bits that are sent. It's more bits that are for error correction. So you can expand the range that the data can travel by 2 or 4x. But I think kind of like expanding the spec over the years to meet these different use cases has really allowed the technology to evolve.
So how does this?
Yeah, so oh, sorry, go ahead.
Simon, how do you see this continuing to evolve, especially with keeping interoperability in mind? You now have devices who might have megabit PHY, right, with packet length extensions and optimized for throughputs. You might have devices that are using the different, you know, coded PHYs or ways to do longer range communication, right? And yet these devices are all labeled Bluetooth, hopefully meant to work together. How is that gonna work?
Well, I think, yeah, there's I guess 2 aspects to it, right? So the first, I think Bluetooth well, not uniquely, but really from the early days had these, you know, unplug fests and all about compatibility and getting all the competitors together and making sure everything worked together. And just that, I guess, momentum of interoperability not just on paper, but of real devices really talking to each other. I mean, that was sort of built into the DNA of Bluetooth, even before Bluetooth Low Energy. So I think that in itself is a really powerful approach. You know, it sets the culture, it sets the tone. But you're right, Bluetooth is adding a whole load of features, which, to Chris's point, is an advantage, but it can be a disadvantage. So I think what you'll find is that you know, certain technologies that make absolute sense in, let's say, the mobile space will just get rolled out and they'll be adopted. Certain things that don't necessarily make so much sense in the mobile consumer space might be more to little niche areas. So I think the technology will be solid, but yeah, perhaps in terms of interoperability, it won't be there in quite the same way, but often that will be in situations where it doesn't matter. You know, so we have people who have been testing using like the Blecon network, like sending Bluetooth communications over a kilometer using coded PHY. You know, that's great, that works, but it doesn't necessarily mean that it would work for your set of new audio headphones that using Bluetooth Low Energy, and you wouldn't expect it to, and the use case doesn't require it. So I think, yeah, that whilst the technology is pretty solid, there will be a sort of diversification of how it's used, almost like the domain usage of that technology. So it's something that's,
and a lot of these things aren't. I mean, I think the part that was smart is in the early days, I think the SIG took in feedback and got some of these features out relatively quickly. So if we're talking about packet length extension or some of this coded PHY support or other things, I think that goes all the way back to 2015, 2016, something like that. And at this point, the adoption in phones that folks are talking to is really getting kind of more and more in place where like people can leverage these capabilities. I think when people design for Bluetooth, you kind of have two core use cases. You have the sort of like, you control both sides, right? You control the peripheral and the gateway you're proxying the data through, or you're sort of leveraging the phone ecosystem that's out there. So you're, you know, talking through an iPhone, or you're talking through an Android phone, or you're talking through a gateway. And if it's like, I want to push the limits of whatever the latest thing is, you want to control both sides. If it's sort of like, hey, we want to like talk to the ecosystem that's out there, building on top of some of the stuff that's been out there for 8 to 10 years is getting pretty stable in the field today.
And I guess this was one of the other, I don't know if it's an innovation or it's just a good technical trade-off, but when Bluetooth Low Energy was introduced, it was very nice that there was a lot of these combo chips. So Bluetooth Classic, Bluetooth Low Energy, and that's what all the phones and laptops and things adopted. But Bluetooth Low Energy understood that actually just having a peripheral has very different requirements, right? So it was, although it was very cheap to add the Bluetooth Low Energy into the silicon that was going into these laptops, you could also build custom Bluetooth Low Energy only peripheral devices, that only need to connect to the host. And that's how you got a big diversity of, or be able to get the cost of these end peripherals really low. So not only the power, but the cost. And I think that observation that it's not asymmetric. So Bluetooth Classic was invented in a world where it was about replacing a cable. And it's quite a symmetric concept, right? There's two things and they want to talk. Whereas Bluetooth Low Energy very much was thinking about really low power, really low cost devices that need to talk to something that can afford to be more capable. And I think that for me, that's something that's really interesting. The loop is that Bluetooth Low Energy is now adopting, LE audio, or has now LE audio and also Auracast, if people have seen that, so broadcast audio. And now you're looking at Bluetooth Classic and thinking, why does it need to exist anymore? But although it doesn't matter, it's not the point.
Still the
really.
largest.
It's a good
Dual
question.
mode radios are still the largest number of shipments, right? Like there's about 5.5 billion Bluetooth devices shipping every year, a mind-blowing number.
Yeah.
And of those, like about 2/3 are dual mode radios, which is it feels like things are changing, but not that fast. Last question on this set of topics. One of the things we've said is that one of the amazing thing the Bluetooth SIG has done well is evolve the protocol and make sure to address use cases as they emerge, right? We haven't talked about ranging or angle of attack type of use cases for localization, but that's also something they've done really well is going after that market as well. When you look to the future, any future features or developments in Bluetooth and BLE specifically that you think are especially notable and people in the audience might want to keep an eye out for? Chris, you want to start?
I mean, from a purely like interesting perspective, I think PAwR feature set and sort of enabling, I don't know how many people follow along with shelf labels and how hard it is to keep a store, updated with the right price tags and variables and mix things in place. And I think like the sort of this functionality that was built out as part of PAwR to support electronic shelf label use cases is just like really, really interesting. Basically gives a way to update a massive amount of devices in one place, sort of exchanging data back and forth over advertisements.
Oh, so it's kind of an extension of the beacon concept where advertisements become part of the data path, right? And it doesn't require any kind of connection.
Advertisements, and then you can actually get responses back.
So over the top message response. Simon, any future?
I'm excited for LE Audio too. It's finally happening. Seeing stuff roll out. So I think that's a really interesting direction where things are headed as well.
Yeah, so obvious one. Well, so there's, as you said, there's a bunch of stuff around angle of arrival, angle of departure, and ranging. So accurate, like phase-based ranging for locationing and things like that. So that's quite interesting. Makes people question, because ultra wideband was one of the things that people were looking at for that sort of thing. But the cost point, it's quite interesting. Is this good enough that actually, ultra wideband is not necessarily the interesting technology in a lot of use cases. So that's quite interesting. But I think, if I'm honest, like what's most interesting if I look into the future is actually where Bluetooth is going to turn up. So in terms of less the adding more technical features, it's the implementation. So it being implemented in more and more chips alongside MEMS, alongside energy scavenging circuitry, and just that proliferation of it as a staple wireless comms. If you look at anyone who's doing, energy scavenging, devices and things like that, they're using Bluetooth, and because that's the one that's fit for the target. If you're trying to put something really low cost and get it in the corner of your die because you need wireless comms, but it's not really the focus. The focus is, the AI processor or the MEMS sensing devices or whatever. It's Bluetooth going in there. There's so many manufacturers making Bluetooth now, silicon manufacturers, that's a great competitive cost market. So yeah, I mean, as much as I love features, I mean, they're great. I mean, Bluetooth is incredibly, incredibly capable. And I think even, to be honest, even with the 5.0 spec, ignoring 6.0, it's got so much untapped potential with the technical capabilities it's got. That's honestly what's exciting to me over the next 5 years is how it's going to turn up and where it's going to turn up. Sorry, it's not quite as geeky as a new feature, but
a good segue into implementation. So let's talk. I'll interrupt you, Chris, just to keep us moving. Let's talk a little bit about designing with Bluetooth and applications for Bluetooth. So we know that the Bluetooth SIG really identifies 4 big solution areas for Bluetooth: audio streaming, think headphones; data transfer, think a fitness tracker or a heart rate monitor, something like that; location services, asset trackers mostly; and then what they call device networks, which is IoT, home automation or electronic shelf label type devices. Simon, I'll start with you. I obviously this is the view of the SIG, but in your opinion, what is Bluetooth good for? In other words, when as an engineer, when you start considering different technologies you might use, where might Bluetooth fit perfectly?
Yeah. Okay. So I mean, good things is where it doesn't fit, right? It's not about it's not about video streaming. It's not about your broadband connection to the internet and things like that, right?
So low bandwidth, I guess, is step 1, right? What's low bandwidth?
You say low bandwidth, but 2 megabits is a PHY. It's even getting pushed up in the later versions. So for a lot of applications, I would consider that high bandwidth actually. It's all relative, right? But you know, so
So maybe let's give some, let's quantify it a little bit, right? Like if I need, what kind of bandwidth should what's the sweet spot for Bluetooth in terms of actual bytes per second or bits per second being transferred in our application, right? If I was thinking about serial transfer, what's the baud rate that Bluetooth would be acceptable for?
Yeah, so I think the exciting thing about Bluetooth is it's incredibly low latency and fast at setting up connections. So so like, yeah, let's say 1 megabit PHY. Okay, so you're getting 100K a second or something like, optimal, but the really interesting thing is it can then also go to nothing incredibly quickly, or it can go to a very small drip of information very quickly from a sleep state. So yeah, there's definitely an upper bandwidth, maximum that if your application requires lots of bandwidth, it's probably not a suitable technology. But what's I think most exciting about it is the fact it can go from 0 to that bandwidth, or 0 to just a very tiny bandwidth incredibly quickly. And that's something that we're exploiting that, and it's quite unique, I would say, as a technology. Whereas if you compare that to a Wi-Fi or a cellular network, often there's a lot of overhead in keeping a connection alive, a lot of power being used to do that. It takes quite a long time to establish connections in reality. When it's up and running, it's it's amazing. You can push amazing amounts of data over, let's say, Wi-Fi or something like that. But that's the steady state. Whereas Bluetooth Low Energy or something like that can be much more reactive, I think. And that gives you a lot more trade-offs, I think, when it comes to things like energy, when you're going to push bandwidth, and when you're just going to be asleep.
So up to moderate bandwidth applications where we're switching the radio on and off quickly and having a low cost of connection might be very valuable. Chris, what about latency or battery? What's the design space there?
Yeah, and I was going to say, in many ways, on the last point, maybe BLE even gets labeled as low. There's a wide scale of low bandwidth, right? Like we work with customers at Memfault that can send 200 bytes a day of data over a satellite. Like that is low bandwidth. Like we're talking about BLE, you can go from 0, no connection, to sending data in the like kilobytes, tens of kilobytes per second range quickly. That's like not crazy low bandwidth. That's like you can actually get a decent amount of data kind of going over there. And then yeah, to the second point, there's a lot of knobs that I think something that's really BLE is versatile. Like there's a lot of knobs that you can turn. Like if you're really focused on these extreme low power use cases, you can really throttle down the rate at which you're sending the data over a connection, be super, super efficient. You can dial it up so you can bring that latency down by tuning the connection interval that's on the device, or where things are there. And so I think that's kind of it's an interesting question. Like if I need, if it's sort of like, hey, I'm not going to be directly connected to the internet, and I need to turn to some protocol to get data between, myself and a phone, myself and a gateway. I think the better question is like, when isn't Bluetooth a good fit? Like I would lean to that most of the time. Like there's a bunch
Let's talk about that. Let's talk about use cases. Simon talked about video, that being just too high bandwidth a use case, and where Bluetooth might not be appropriate. One of the ones that I'm aware of is latency, of course, like very high latency or applications that require very, very low latency can be challenging with Bluetooth, right? I worked on VR, virtual reality controllers, which needed a very, very quick feedback loop for the user so that it would be rendered and seen in VR as they moved. And their latency was problematic using Bluetooth. We ended up rolling out some custom wireless protocols, right? What's the envelope there? What's the kind of application you might not use Bluetooth from a latency perspective?
Yeah, I mean, so you're basically at the mercy of how low you can tune the connection interval on the device. So basically the sync point where data is exchanged back and forth, and then the amount of data you want to send at that point. But like connection interval, you can negotiate down to something like 7.5 milliseconds as like the fastest. Like most phones kind of operate in like a 15 to 30 millisecond range. So, I mean, definitely for like VR, AR use cases, if you're trying to push a lot of stuff or react quickly, it can add up as there's like back and forth that are there. But I think for most use cases, like that's acceptable. I guess like and then I was just trying to think of other areas where, maybe Bluetooth isn't a good fit, and maybe it's like the super, super extended range. If you're trying to like pipe data over, beyond a kilometer to somewhere else, like there's other technologies you can lean into there. But for I look at a lot of legacy products where there's, sub gigahertz protocols that are sitting amongst devices in the house, and there's no way to actually, sniff that traffic and understand what's happening and figure out what's taking place. Like the debuggability is really challenging. And if I were, designing a product from scratch myself, I'd be like, pick the one that has an open standard, that has sort of access to low-cost sniffers that like a lot of the world uses, and there's good conversation about on the internet, so you can learn, how it works and how it's in place. And I think in many ways, like BLE might be the most widely discussed RF protocol out there for like transmitting data in the world.
Yeah, hidden in plain sight is what we think about.
Simon, an obvious one for you, of course, is Bluetooth. Whether or not Bluetooth is appropriate when you need cloud connectivity, right?
Right. Yeah. Well,
what's the design space there? Of course, Bluetooth's not going to replace LTE anytime soon, right? Or even 2G type lower bandwidth cellular applications or narrowband IoT. So what's the when we think about more wide area connectivity or direct IP connectivity, what's the place for Bluetooth and the place where it might not be appropriate? I know you think a lot about that.
Yeah, well, yeah, we think about a lot about that. Yeah, I mean, again, a lot of the things that Chris was talking about, why people turning to Bluetooth, it's because they want to leverage ecosystems, they want to leverage tools, they want to leverage stability, expertise, economies of scale, all this sort of stuff. And people have been using Bluetooth to connect to cloud services for years, right? It's you guys worked at Fitbit, I'm sure. The phone talked to the Fitbit device, and then the phone talked to the cloud, right? And indirectly, that's what it was doing.
Well, actually, let's put a pin in that for a second. Chris, do you want to talk briefly about how sophisticated that actually can get, right? There's an open source project from Fitbit called Golden Gates.
Yeah.
And basically how the amount of work that companies like Fitbit do,
it gets complicated
to abstract away the connectivity and try to pretend like the Bluetooth device is directly connected.
I will say maybe that's one area for improvement between Bluetooth Classic and Bluetooth LE is initially if they put in place some sort of serial streaming protocol or API and not sort of just exposing GAT services. I think it would have made a lot of people's lives a bit easier when it's like, hey, we want to send big payloads of data. We have a small MTU size. How do we like pipe this data to the phone so it can be forwarded to the cloud? I think any company that's deployed BLE devices at scale knows what I'm talking about, where they've designed.
So L2 cap APIs are now generally accessible in platforms.
They're finally out there.
We're exploiting that. So yeah, I totally agree.
But it can get complicated. I guess to sort of François' question, it can get complicated quickly because there's a few different layers of expertise that you need there. There's, the firmware design side and getting the stack to connect to the phone. There's the mobile application development piece where you need to understand, how to use either the iOS or Android APIs to interface with the device. And then there's the forwarding problem of getting the data to your cloud service and what's there. And then there's always kind of the debate of, I'm encrypting the connection between the device and the phone, then I'm reading it on the phone, and then I'm forwarding it to the cloud. How do I create, a pipe that just passes the data through to the cloud so we can decrypt it there, which I'm sure is like all topics you dig into, Simon, but it can get into
as a firmware engineer, personally, I wish I didn't have to know whether there's gateway or not, right? And that's, to your point, Simon, companies who try to build products that depend on a mobile phone as a gateway or some other, home automation gateway, whatever it might be, oftentimes don't have that luxury. They have to know there's a gateway. They have to actually write a custom set of payloads and packages between the.
I spent 10 years watching companies do this. So,
Right.
so yeah, luckily when I was at ARM, we were building mesh networks, which turned into Thread. We were building LTE, NB-IoT and Cat-M silicon modems. We were building Bluetooth radios. We were, dealing with lots of these different radios. So and the number of times people are, they're using Bluetooth for all the right reasons to make it fit, right? And this is what a lot of people ended up doing. And in your case, what's interesting to me is you're doing all that work, and a lot of companies can't afford to do that all that work. But that shows it already has utility in this mode. There's a reason why people are doing that rather than your Fitbit just having a cellular modem in it, right? They wouldn't, otherwise they've just put a cellular modem in it. But I think
the power situation is a bit tough there.
Yeah, the power, cost, also, yeah, exactly. But the other observation I started to see a lot with companies was, Bluetooth grew up in consumer. So a lot of people doing what you were talking about there, but then also people trying to apply Bluetooth in non-consumer, where there isn't necessarily the personal relationship. And Bluetooth is about, effectively take your device, your Fitbit, and plug in a virtual wire to your phone. Well, that works in the personal situation, even if it is a load of engineering to do that. But when you want to break that sort of personal connection, because as you say, it's more just the device just wants to connect to a cloud. It's not about a person. Actually, some of the there's even more work to do. Actually, the pairing model breaks down, the security model breaks down. So that's what we've spent a lot of time working on. So I mean, people for years have been using Bluetooth for cloud connectivity, as far as I'm concerned, even if it's not architecturally pure or they don't think of it like that. It's been happening more and more, and it's exploding. And then I think the fact that Bluetooth Low Energy also supported beaconing and that got really adopted in asset tracking and things like that. And now those asset trackers want to start communicating more than just their location. They want to start communicating data. There's this really interesting convergence at the moment of the sort of locationing, beaconing world wanting to become more intelligent, and the Bluetooth personal world wanting to become less personal. And it's just a really interesting thing. So I think the future is incredibly bright for Bluetooth outside of consumer electronics and just shouting that I'm here.
In many ways, in the consumer space, the last point I'll add there is kind of that, the goal is the data makes it to the cloud. So insights can be driven or people can be updated on what's there. And like what slows down the pace of development is kind of having to coordinate those pieces to get your your stream or your packet there. So across the board,
a firmware engineer and a mobile engineer to agree on the structure of the packets being exchanged. Terrible. we've all done it.
So the observation we had, and it's really depressing when you see companies not failing, but struggling like this. There's the device guy, he knows what the widget's got to do. There's the cloud guy, he knows what he's got to do. And they meet in this middle, in this app that no one really owns. But that fundamentally is the owner of the architecture. And actually that thing in the middle becomes such an important citizen in the architecture. It becomes an actor in that architecture, which if you looked at Wi-Fi or if you looked at a cellular, the idea of running
the router,
running something on the cellular cell tower or running something on your Wi-Fi router. I mean, obviously people do things like that, but it's just not how you think about architecture. Anyway,
Simon, one more question on this topic, which is what about the IP profile?
Mm-hmm.
We've been talking about IP over Bluetooth for a long time, right? But
I mean, it's even in there, right? There's various things in there, but it's just not.
As far as I know, I have never seen a product that implements it, right? I don't even think the mobile phones implement the profile. So...
No, and it's strange. Like I think there was definitely an era, I would say 10 years ago, where it was all the research into sort of wireless sensor networks and things like that. It was all about IPv6. Everything has got an IP address. And there's loads of work done in that. And to be honest, some of that is turning up in things like Thread and things like that later on after many generations. But a lot of it is, I mean, I don't want, I don't want to be rude about it, but it's quite academic.
Mm.
Whereas what I love about a lot of the companies we're talking to at the moment is they're incredibly pragmatic, and it's not about architectural purity. It's about, you know, solving a problem with the right technology that's good enough on multiple dimensions, not just you know, those sorts of things. So if you think about the technology that's in phones, you know, which is primarily dominated by Android and iOS, so Apple, what technology goes into there is absolutely dominated by delivering opportunities for their customers, which are, you know, people using mobile phones. And that shapes a lot of what technologies get deployed. So the reason that beaconing became, you know, got a bit of weight behind it is because Apple wanted to use iBeacon to tell you when you're in Starbucks. And then Google went, oh, well, we need a version of that as well. So they did Eddystone. So like Sam and co at Google doing those sorts of things. And, you know, I worked with that team, helped them build like the early beacons they were doing. And, you know, they were totally focused on marketing. So that was what got it in there. And then it was the industry that went, oh, hang on, we can track things rather than track people. But I think without that marketing push in the first place, the reason for that technology to get into the phones, it wouldn't have happened. So yeah, I think unfortunately some of this doesn't follow logical paths.
Basically, Apple, what I'm hearing from you is Apple doesn't really have a use case internally for using IP over Bluetooth, and therefore they're not really prioritizing it. And then
yeah,
maybe
I mean
someday they will.
that's definitely changing with like I say, Matter and Thread,
Right.
Because a home automation network is
Requires
a thing that the industry has been trying to crack for years. And you know, Zigbee didn't really do it. The Zigbee is now CSA, and you know, now that is in phones, so that's quite interesting. But yeah, it's incredibly use case driven, which I think is the right way to do it. And that's why a lot of people are using technology where it doesn't feel like it's perfect, but for lots of reasons, it's exactly the right pragmatic solution. Yeah.
Yeah, Bluetooth wins because it works oftentimes, and it's there, it's cheap and well understood.
It's global. People know you can hire engineers, you can buy test equipment, people know how to sign it off, you can get it certified in different countries. You know, this is all important stuff.
Barrier to entry is low as far as kind of like RF protocols are concerned.
Let's spend the last 7 minutes before we go to questions talking about, you know, how do we operating Bluetooth devices in the field? What are the common pitfalls? You know, building a device is one thing, making sure it works all the time is another. I think we've all seen just Amazon reviews. If you go on any Bluetooth device and you look at the Amazon review, you will find a review where they say, I can't get it to connect or pair with my phone, right? For example, Chris, I
feel like they never blame the phone too. I maybe have a lot of scar tissue working on the peripheral side.
So interoperability is problem number one, right?
That's always the peripheral's fault in these reviews. But it's interesting because, you know, something that is certified and tested very thoroughly is kind of at the base layer, you know, RF protocol, how are things sent, how do things look? Like that's the part that gets the heaviest degree of testing as these devices are being built or as new feature sets come out there. But the layers that are on top, this interoperability piece where you can negotiate connection parameters this way, you can use this feature versus that feature, you can exchange items back and forth. There is a wide variation of behavior you can get out there as new chips are brought in the market and things that are there. So like when I worked at Pebble and Fitbit, something I spent a lot of time doing was understanding the ecosystem at the time. What features are we seeing supported on different versions of iPhones? What features are we seeing supported on different Android is a lot more diverse, but basically based on the AOSP version or based on the phone that's there. What you can start to pinpoint is there's always like some bucket of problems that are specific to new phones coming on the market that haven't fully implemented a new feature that's there, or legacy phones that are on the market that are still widely popular.
How do we guard against that? Like, let's say you're an engineer and you're tasked with building a device that connects to phones.
It's pretty low level, but there's like two things that I always like to collect. There is every time a Bluetooth connection is open, there's a link layer sort of packet exchange that takes place where both sides send two types of information. One, the vendor that each chip comes from, sort of like codes that you can look at, where basically you can figure out effectively the Revo silicon and who made it. And then 2, the features that are supported. There's a version indication request and a feature exchange request. That's sort of my baseline for like, at a high level, I want to understand what's the distribution that we're seeing
collect
out
that
there.
data in your product, basically, is what you're
Collect
saying.
the data in the product, and then start to measure how well your connection is working. And depending on the use case, I mean, there's basically like 2 BLE use cases. You're connected all the time, right? And so like how often, if your goal is to be connected all the time, right? Your fitness band or things are there. How often are you actually connected all the time? And then there's the other use case where the device is waking up to exchange a small amount of data. If you're in that use case, when you try to send data, how often does that succeed? You kind of like correlate either of those with kind of this distribution of like what phones or what devices are out there, what features are being negotiated. You can start to pin down, hey, I'm seeing lots of connectivity issues when I'm trying to use packet length extension or whatever it may be, and then dig down based on the modeler piece that's there. But that's
so what you're
usually where I
saying
start.
is if you have some sort of way to collect data, like an observability system to collect data from your Bluetooth devices, you might want to collect some identifying information from your Bluetooth central, basically the device on the other sides, and then collect some connection health statistics, so that you can start correlating and find your kind of 3 worst devices that your customers pair to, so that you can then buy those devices and investigate yourself, right? Like that definitely sounds like a good one. Simon, any if you were trying to, what kind of diagnostics would you collect? How would you, if you were building a Bluetooth device tomorrow, what kind of information would you make sure is available to you, so that when customers inevitably complain, you can do something about it? Is there any connection parameters or other things that you think are key?
Well, I mean, I guess a lot of this is about you have a sense of your expected behavior. So, do you expect connections to be dropped? How long do you expect them to, last? Simple things like how long are you spending asleep? How's your battery doing? It may, a lot of, you don't have to identify the cause. You can just identify the symptom often, and that might get you out of jail. So yeah, being able to understand how much energy is being used. A good example is, Bluetooth actually is quite a reliable transport, but part of that is because it can automatically do retries at, certain levels of the stack. Now, you might think your communications are getting through fine, but actually, it's causing a lot of retries, which could make your calculations for battery life of your device totally out of whack. And that's why someone is reporting that this thing has just not got the battery life that was promised, or something like that. Now, you wouldn't see that in errors or connection drops or anything like that, but actually, the throughput you're getting and the amount of retries that might be happening or something like that could be really impacting things. So I think, things that allow you to smell out those sort of problems can often be quite simple. What is the energy, or what's my battery level, or what's
I always find BLE throughput really fun, because there's like a number of different knobs you can turn. And then when you're talking about most of the end devices that you're chatting with, there's coexistence that comes into play between sort of Wi-Fi and Bluetooth Classic and BLE that's there. So if it's a throughput intensive application, you're trying to send 100K of data, measuring sort of what that is can be really interesting to look at as well, because then you can sort of start to understand, on what types of devices am I getting high throughput and what types of devices am I getting low throughput, and look at the patterns that are there.
And I remember, I think
we spent too much time
debugging connection interval, right? At PAwR, Chris, do you want to tell a little bit about why they might even want to track some of these connection parameters, so that they can figure out why a specific customer might be complaining? What connection parameters would you track?
At PAwR, and I guess to take a step back there, at PAwR, a big thing we focused on was that out-of-box experience and wanting that firmware download to get to the device as quickly as possible, so someone could start to use the device and wire things up, which necessarily led to, how do we transfer the data most efficiently, the OTA payload between the mobile phone and the application. It was kind of the thing where we found, some customers, the download was super quick. Some customers, the download was like 10x slower than we thought it should be, or where things should be in place. And that's where, that was where looking at performance for collecting connection parameter information about sort of what was being negotiated was really helpful. Not all stacks expose it, but the way the BLE protocol works, you send a packet and the other side basically says you can continue to send me more data or not. And different phones or different stacks over the years, some of them will say I'll only ever accept 4 packets in a connection interval. And understanding sort of like what the makeup is of those different phones can let you figure out how to make sure you fill the available bandwidth with data still being exchanged.
We have about 10 minutes left, so let's take it to questions. Chris, I'll start with a question for you. Ivan asks, what is the easiest from a firmware engineer perspective, Bluetooth SDK for embedded devices in your experience? So if you were picking a stack, picking a chipset and an SDK to build a device with, which might it be?
Yeah, I think if you're getting started and looking for sort of an accessible SDK to go wire up, where I would go these days is one of the NRF chipsets or things that are there. NRF
from Nordic Semiconductors.
NRF 53 or 52 SDK. It's built on top of Zephyr, so that's kind of good, big community, a lot of information that's there, a lot of documentation online about what's in place or where things wire up. I think that's a really good stack to
get all on GitHub.
It's all on GitHub.
They have a great support on DevZone. Yeah, I agree that
they also, I think the other part that I guess the other call out I would add there is when you're starting to get into Bluetooth, I think spending a little bit of time understanding how the protocol works and sort of what's being exchanged back and forth will let you make the right decisions as you're trying to optimize for throughput or power and understand the trade-offs. And something that is neat is one of the NRF dev kits has been reworked as a packet sniffer. So they basically there's basically a firmware you can flash on the dev kits that turns it into a sniffer that can tell you, hey, here's the packets that are being exchanged back and forth. And I think that's very accessible.
Simon, we have a slightly inflammatory question from Roberto, and I figured maybe you know the answer. He asks, why does Matter limit the usage of BLE and its BTP layer for commissioning and not for the application layer? So in other words, Bluetooth in the Matter protocol can only be used to commission devices, not really to exchange data as part of the application. He asks, is this political or is there a technical perspective?
It's actually quite an interesting question. So a lot of the Matter is sort of this object model for things that sits on top of like an IP connectivity, which might be Wi-Fi, it could be Ethernet, but it also could fit on top of Thread, which is a 15.4 based meshing radio that's gone through various iterations. So a lot of that technology was built with this idea of IPv6. This is how it talks. And if I was being honest, there was a lot of time spent on that. And then people went, how do you set it up? And this is actually a general problem. I think a lot of people spend a lot of time on the steady state and thinking about that and optimizing that or whatever, and overlook the 10 seconds of a product's lifetime, which is, let's say, the setup or something like that. But actually, in my opinion, it's kind of flipped. 90% of your engineering is actually getting the product to the steady state where it's working. That's what costs money. That's what costs support. That's what,
Right.
So if I was being rude, I'd say it was thought about quite late. It's not quite true. It's not quite how, so we were building the Thread stack at the time, and, we were involved in all of that. But yeah, and well, if you're going to set something up that hasn't got a user interface, well, what do you use? We use a phone. Okay, so the first versions were very much like you joined the phone to the network and you did it over the network to itself, and you had this sort of bootstrap problem. And most 15.4 radios are now built as multi-mode radios. So you can run Bluetooth or 15.4 on the same physical silicon, and they can run in parallel. So a lot of the work we back in the day was trying to make them work at the same time. So it's actually quite practical. Yeah. So I think, luckily this is pragmatism coming to it, and Bluetooth becomes the right way to commission it. But yeah, it's a really good question. Why Bluetooth? I don't actually know how political it was. I don't think it's really that. It's just there was a problem to be solved, and it was solved in the most practical way. but it was solved relatively late, in my opinion. So yeah, sorry, I know that's not quite the it's not quite the controversial answer you were perhaps looking for, but
No, Noah asked about LE audio adoption and whether we see it replacing, AVR-CP eventually, the classic audio profiles. I'll just note that today LE audio represents maybe 2 or 3% of device shipments, of audio device shipments, and the SIG forecast that by 2028 will be closer to 15. So still relatively small.
It's a really interesting
LE
migration
only
problem.
LE only, like I'm talking about LE only audio devices, right? But do you guys think it's inevitable that it will be all LE audio eventually, or is it still very much an experiment?
Oh, it's definitely not an experiment, but I mean, inertia, and there's so many cheap chips that with OEM designs that know how to make headphones that or wireless speakers and things like that that's not necessarily going to be easily replaced. That's NRE that's already been invested, chips that have already been invested that can be pumped out incredibly cheaply. But yeah, I mean, I think LE audio, certainly the industry believes it's going to be successful, and especially when you've got like earbuds, separate earbuds, it's not a wire between them and things like that. There's a lot of features in there that means LE, I think, is going to be successful. But yeah, I mean, your stats sound spot on. It's gonna definitely have a impact, but it's not going to flip over.
Not overnight. Do you think
maybe never at all?
If you were designing a device, and considering audio capability for your device, would you bet on LE only, or would you put a dual mode radio today? Right?
There has to be. I guess this must be a really interesting debate at phone manufacturers or other companies at the moment, where it's like, at what point can we just go LE only chip, cut down sort of some of the space on the board, the BOM that's there. But I think for a while you're going to have to do the dual stack to support both modes because of the devices on the other side.
Yeah, I mean, if it's a peripheral side, if you're talking about peripheral side, then
yes, peripheral side.
Then I think you understand your market, right? If you're building a Bluetooth speaker that's meant to work with whatever, that's very different to building some really high end headphones that you expect to be pairing with the latest smartphones or something like that. So I think that's it's perfectly reasonable that a set of headphones could be sold, or even hearing aids or whatever, sold as only working with this level of technology and beyond. I think that's quite likely. I think that's probably where the penetration will come. Yeah.
Simon, we have a question from Jacques Moreau, who seems like a layup for you. He says, I'm not a mobile developer. What tools can I use to develop a BLE app on a Linux device on a Linux host for interacting with my MCU or my BLE dev kit? So in other words, if I don't know how to build mobile apps, what gateway can I get, right?
So I'm not sure if I quite understand the question. There's a Linux. You said there's a Linux. Linux is the dev platform.
Yes. I'm using Linux on a dev platform. I want to interact with a BLE dev kit connected to the clouds. I don't know how to build mobile apps. What's the easiest way to connect my BLE device?
Well, yeah, I mean, it obviously depends on the use case. Yeah, I mean, for us, that's an easy answer if it's the right use case, which is the stuff we're doing at Blecon is all about cutting out that middle infrastructure. So if you're building, you were talking about like the Nordic parts, with the 52, the 53, or the 54, something like that. Blecon is about build on a microcontroller platform, and your comms ends up in the cloud, and you don't have to go near an app, you don't have to go near a gateway, you don't have to do any of that stuff. That's all provided for you. That's great.
What's the easiest way for people to get started with Blecon? Because somebody was also asking that question. If Jack wanted to check it out, where should he go?
To the website. We've got images for like even like the latest Nordic chip. So the Nordic last week announced the NRF 54L, which is a really super exciting chip because that's basically the next generation 52. We've got images to turn that into a modem. We've got an SDK that you can get off GitHub to use, and you can just get an account on our website and try it out, or obviously just give us a call if you want to understand.
It's blecon.io.
We're not that cool. No, it's Blecon.net because it's a network.
Blecon.net. Okay, great.
I have got that domain, but
And
but yeah, that's the thing. But depending on the application, yeah, it might be that, or it might be get an MCU kit and start poking around, yeah, on your Linux machine.
Joe asked us about, so his exact question was, is it relevant that Bluetooth was going to transition to using UWB in 2003 or 2004? That's news to me. I'm not quite sure. I'm not quite sure in what, how much interplay there was between Bluetooth and UWB, both in terms of the spectrum and in terms of the technologies. But Simon, given that that's something you're pretty familiar with, maybe you can talk a little bit about the history of the relationship between Bluetooth and UWB.
Yeah, so so the different trade-offs, different technologies, quite different technologies and implementation. And I think the reality is, so ultra wideband has had lots of false starts. There was going to be an ultra wideband USB, wireless USB standard. There was going to be an ultra wideband sort of Bluetooth-esque competitor. Are they friend? Are they foe? Yeah, I mean, I think the reality is that the use cases that it was trying to address, Bluetooth Low Energy hit the nail on the head enough versus the additional complexity and of fitting in something like ultra wideband. Like I said, one of Bluetooth Low Energy's like trump cards was the cost of implementing it on the host device, so the phone, the laptop, or whatever, in silicon was, I forget exactly, like 15% or something. It was very small. Same frequency, same antenna, all of this sort of stuff. So that one, yeah.
We have Ivan, who asked us about the SDKs the last time around, said, what is the second best SDK for developers? Mostly because he's very familiar with Nordic and wants to learn more about what else is out there. Like if you couldn't use Nordic, what's your next choice? Simon, you wanna go first?
I mean, I don't want to. I love all the silicon vendors equally. Nordic more so at the moment because that's the primary one we're working with. But yeah, I mean,
maybe you could just pick stacks themselves that target sort of multiple chips or pieces. So there was the kind of been upstreamed into Zephyr now, right? But there's the Nimble stack that was part of the Minute stack, sort of ported to several different.
That's an open source Bluetooth implementation.
It's an open source Bluetooth implementation, which I do think is interesting to read through or look at to kind of get an understanding of, if you were, I guess, as we were talking today, a question in my mind as like more and more Bluetooth chips has showed up is how many people, how many different Bluetooth stacks have been written across the wide array of silicon that's available for things today. But if it's kind of like taking a step back, I think it's the only one I'm aware of that's like truly fully open source, and you can really build an understanding of.
I think there's the packet craft stack together also, which is open source, or at least partially open source.
Yeah, so John and Jason, who did Packetcraft, they've done loads of stuff on Auracast and LE Audio, which is really cool. But yeah, I mean, stuff like the Silicon Labs chips are very well. I think there's a lot of good things. I think there will also be a consolidation in software over the next few years, which is really, I think, an interesting thing. So things like the Zephyr operating system. It's finding its feet in certain silicon vendors, but I think the story will be quite different in a few years' time, and that might actually change the story from which chip to which software should I test. So I think if you were I get the question as being if you were starting now. Yeah, I think starting with a Zephyr-based Bluetooth implementation, whatever chip that happens to be one that you run it on, would be a great place to be starting. Partly because you can learn on any of them, but partly because I do think it will become more common across multiple silicon vendors over the next few years. So I think it's quite a good bet.
Yeah, across the board on our side, we continue to see more and more semiconductor companies bringing sort of ports and implementations over to Zephyr. So I think just building an understanding from that side or playing with different chips there is an interesting place to start.
Yeah. And you'll start to see more of that activity become official next year. So we can't talk about that, but it's a good bet, I would say, if you were learning.
I'll have one last question from Jeff, and I apologize to the folks whose question we didn't get to. But Jeff asked a question that I actually wanted to ask, so selfishly, I'll call it out. He says, it seems that Bluetooth mesh adoption has been lower than expected. Why is that? And do you think and do you think this is going to change? This is definitely something I've seen, right? Like Bluetooth mesh has not really arrived.
Yeah. And I don't think it will, if I'm
Simon,
honest.
tell us.
Yeah, so in our world of playing with all sorts of different mesh stacks and building mesh stacks, you learn a lot about the realities of these types of technology. So again, mesh has a lot of good properties, but it also has bad properties. And one of the general meshing problems is nodes become a repeater. So the amount of energy you're using and the amount of effective bandwidth of your network goes down as a proportion to the number of hops. And so you have to decide, are all things equal? Am I willing to spend my battery power on sending someone else's message, and et cetera, et cetera? So there's that aspect. And then there's also the specific implementation of how meshing was done in Bluetooth, which is more like a flood mesh sort of thing, where one thing shouts and then they repeat and they repeat. So it found its home sort of tried to find its home in lighting. And what's unique about lighting? Well, it's very low bandwidth, control of light, and it's powered. So actually kind of worked enough for that. But not enough. So yeah, I mean, I don't see Bluetooth mesh as being it might have a niche use case and things like that.
It's truly limited on the bandwidth side too. It's kind of,
and the repeating is honestly, I'm not sure that honestly, I think in part the technology is not quite ready in some ways. Like I have some memory of trying to get firmware updates, with a Memfault customer who was trying to do firmware updates over a BLE mesh, and they're like thundering of the packets being sent across the whole mesh was just complete madness, right? It's like there were so many retries required. It was so unreliable. Chris, do you want to reopen that can of worms?
No, we don't have enough time for that story. But I mean, I think that's an interesting conversation at some point, would be like when to use mesh. Like there are applications where it makes a lot of sense, but it uploads the complexity by like 100x. Like OTA and kind of distributing things out and getting things in place, really challenging. Figuring out, what's actually going wrong in the network, really challenging problems.
Yeah, and that's just from a technical point of view. That's so actually building it is quite hard. But what is quite revealing is when people come to deploy it, and actually the complexity as a customer trying to deploy this technology and reason about the system. It's really hard. This is often hidden, right? So the complexity of reasoning about a system, which is very dependent on where you place things, and the bandwidth is dependent on where you place things. It's quite a hard problem to solve. So fan of mesh in some things, but I think sometimes it's held up as an amazing solution, and in some situations it's exactly the right thing for infrastructural cost trade-offs and stuff like that. But I think some of the downsides, once you've seen them, you realize why in certain situations it can really not be fit for purpose. Not to say that it's not great for some situations.
I think the fact that they're moving away from mesh for the electronic shelf label use case tells you that mesh is probably only very narrowly useful, because electronic shelf label, you would think very low bandwidth, like that the mesh application, the mesh technology would apply well. But in fact, even the Bluetooth SIG is now recommending their, advertisement-based broadcasts communication rather than mesh. And so to me, that tells us that mesh maybe is failing as a technology. Chris?
Well, I don't think mesh in general, but yeah, I would
Bluetooth mesh.
I think if you are using Bluetooth mesh, you should really understand the technology and the use case. I wouldn't go, oh, that's an interesting technology, I should use it. I think you really need to understand why you're using it, what the trade-offs are, and then wield it in the right way for the right application. Maybe it's great, but yeah.
Are you aware of I'm not aware of a good solution or sort of off-the-shelf solution if someone even went the BLE mesh path, where they'd be able to update the mesh network super easily or readily. Like I think that's something that they would have. Yeah, I think that's something
there's not a good solution out there today.
I don't think there's any. That's one of the challenges too, because like it's a lot of complexity. I don't think there's a really good way to like get the thing out there, which just ups the level of design you have to do up front before you launch things. Because it's sort of like, we have to make sure this thing is perfect or go to all of our sites and update it.
In our case, so in Blecon, like the Bluetooth devices are talking through any hotspot that happens to be nearby. So it's very flexible which hotspot, like a cell modem, but it's definitely not meshing. And it's quite interesting that people just assume meshing as how things magically happen. It's like it almost becomes an interchangeable word, but it's most things actually are star topology. But maybe with roaming and mobility and things like that, but they're generally a star topology. A lot of successful things are.
As always, people sometimes confuse what they're trying to accomplish and how they do it, and sometimes you can accomplish the seamless networking and transition without actually using mesh technologies.
Yeah.
On that note, we're gonna stop here. We're about 12 minutes over time. Thank you to the 30 or so of you who are still listening. I really enjoyed the conversation. Thank you, Chris. Thank you, Simon, for joining us today. Thank you to all of our attendees and listeners who shared questions and participated in making this a successful event. We will share about the next one of these. The recording will be available. The last things that I'll say, there is a couple of things. You can hear more about Blecon at blecon.net. They're also, of course, on social media, LinkedIn, Twitter, you name it. Or x.com. Memfault can be found at memfault.com, and similarly on different social networks. Blecon and Memfault actually wrote a white paper together that you can download. We will share the link, and we'll also make the recordings of this available over the next few days. Thank you, everyone. I hope you have a wonderful day. Simon, good evening. Thank you for joining us. And thank you for a great conversation.
Yeah, it was a pleasure. Thank you.
Loved all the good questions. I enjoyed the mesh tangent at the end.
Bye, everybody.
Guys.